Welcome in everyone. On this episode of Renewable Energy Reality Check, we discuss plug-in solar, also called balcony solar or microsolar. The idea is almost offensively simple. A small solar panel, a compact inverter, and a standard wall outlet. That's it. No contractors, no permits in most places, no roof required. You place the panel on your balcony or patio, plug it in, and it starts feeding electricity directly into your home, quietly offsetting whatever your appliances are pulling from the grid. The meter slows down, your bill shrinks. This isn't some fringe concept. Europe has been doing this at scale for years. Germany alone has over 250,000 of these systems installed. Austria crossed 75,000. The Netherlands hit 250,000 households. And now, the United States is catching up fast. Here's what's changed. Lawmakers have started paying attention. In the US, state after state is introducing legislation specifically designed to make plug-in solar legal, safe, and accessible. California has Senate Bill 868 currently working its way through the Assembly, which would give tenants the explicit right to install these systems, cap them at 800 watts, and require utilities to accept them without mountains of paperwork. Colorado's HB 26-1007 passed the House with bipartisan support. Connecticut's HB 5340 is already signed into law. Delaware, Illinois, Maine, New Jersey, Utah, Virginia, all moving in the same direction. The through line in every single one of these bills? 3 things: an 800-watt output ceiling, safety certification requirements, and tenant protections. Landlords, under most of these laws, cannot simply say no. They have to provide a documented reason, usually a safety or structural concern, or they have to allow the installation. For renters, that's significant. Roughly 44 million American households rent. Until now, most of them have been completely locked out of solar. Plug-in systems change that equation. The core technology comes down to one small but important device, the microinverter. Solar panels produce direct current DC electricity. Your home runs on alternating current AC. The microinverter, typically built right into the plug-in kit, converts the power on the spot at the panel level before it ever enters your home's wiring. Modern microinverters from companies like Enphase, AP Systems, and Solar Edge operate at efficiencies above 97%. They include automatic anti-islanding protection, which means if the grid goes down, the system disconnects instantly to protect utility workers. They comply with UL 1741 and UL 3741 safety standards in the US and the VDEV 0126-95 standard in Europe. The 800-watt limit isn't arbitrary. It's the threshold below which most electrical systems can safely absorb the output without triggering complex grid reviews. Below 800 watts, interconnection fees are typically waived, paperwork is minimal, and approvals, where required, are usually handled within 10 business days. Europe didn't arrive here overnight, but it got here well ahead of everyone else. The European Union's Directive 2024/1711 established a harmonized framework across member states, simplified registration, standardized technical requirements, and strong protections for tenants. As of early 2026, 24 out of 27 EU countries have fully transposed that directive into national law. The results are striking. EU-wide balcony solar capacity grew from roughly 5 gigawatts in 2024 to an estimated 18 gigawatts by early 2026. Urban adoption in particular has jumped 30 to 40% year over year. France has approximately 120,000 units installed, with a 30% tax credit on installation costs and grants of up to €500 per system. Italy matches that number, 120,000 units with a 50% tax deduction under its eco-bonus scheme. Portugal cut its VAT on solar equipment from 23% down to 6%. Spain processed registrations for new installations in as little as 48 hours through an online portal. The model works. The question in the US is not whether it will happen, but how quickly the regulatory patchwork catches up. It would be misleading to pretend this is friction-free. Utilities have raised concerns, and not all of them are unfounded. When thousands of small distributed systems start feeding power back into a grid designed for one-directional flow, it creates real engineering challenges. Voltage fluctuations, frequency management, the need for bidirectional meters. Some utilities have pushed back on net metering for plug-in systems, arguing that the compensation structures developed for rooftop solar don't translate cleanly to 800-watt balcony panels. In California, plug-in systems qualify under NEM 3.0 but receive slightly less favorable export rates than full rooftop installations. Oklahoma doesn't yet mandate net metering for these systems at all. Supply chains are another variable. Microinverters rely on semiconductors. Panels depend on polysilicon. Both have been subject to price volatility and geopolitical pressure in recent years. And then there's the HOA problem. Even where state law protects tenant rights, homeowner associations have been slow to update their rules. Some still impose de facto barriers through aesthetic guidelines or approval processes designed to exhaust rather than evaluate. The trajectory, however, is clear. The global plug-in solar market is projected to grow at 15 to 20% annually through 2030. The U.S. market alone, currently around $450 million, is expected to approach $1.2 billion by the end of the decade. The EU market is on a parallel path. Battery integration is the next frontier. Right now, most plug-in systems simply feed power into the home as it's generated, but manufacturers are developing plug-and-play battery add-ons, small modular units that store excess generation for evening use, for grid outages, or for load shifting during peak rate hours. Enphase, Tesla, and a growing field of smaller innovators are all working in this space. Smart inverters are getting smarter. AI-driven energy management systems are beginning to optimize when a plug-in system charges a battery, when it exports to the grid, and when it prioritizes local consumption all automatically based on time of use rates and weather forecasts. And the 800-watt ceiling isn't permanent. Several states and EU member states are actively studying whether to raise the limit to 1.2 or even 1.5 kilowatts as grid infrastructure modernizes. France expects to revise upward by 2028. Spain is evaluating it now. Plug-in solar isn't the complete answer to the energy transition. It doesn't replace rooftop systems, utility-scale farms, or grid infrastructure investment. But it does something those solutions can't. It puts renewable energy in the hands of people who rent, people in apartments, people who don't own the roof over their heads but still own the sunlight hitting their balcony. That's not a trivial thing. That's 44 million US households and hundreds of millions more globally who for the first time have a realistic path to generating their own power. The plugs are ready for the wall, the panels are ready for the sun. The question is, just how long will it take America to catch up? That's all for this episode of Renewable Energy Reality Check. If you haven't already, check out some of our other videos from the series. You're sure to learn something new.